Good afternoon. Welcome to today's EAStalk webinar on improving aquafeed efficiency through agri-technology. My name is Anna Veskovic, and I'm delighted to have you join us for this insightful session. As the global population continues to grow, the demand for sustainable and efficient aquaculture practices becomes increasingly crucial. In intensive aquaculture, feed costs represent over 50% of the total production expenses. Therefore, enhancing feed production efficiency is not just an economic necessity, but also an environmental and social imperative. Today, we are honored to have Dr. Antonio Chalaris with us. Dr. Chalaris is the Aqua Business Development Manager for Devenish and serves on the board of directors for the European Aquaculture Society. With over 14 years of experience in commercial aquaculture, specializing in marine hatcheries and feed innovation, Dr. Chalaris has been at the forefront of developing solutions that drive industry efficiency. During this presentation, Dr. Chalaris will share valuable insights into the solutions development over Devenish's 70-year history. He will explore various methods to improve protein utilization and milling efficiency through advanced moisture management techniques. These innovative technologies aim to reduce cost, optimize pellet quality, and enhance downstream performance. The European aquaculture industry is a champion of efficiency, yet there is always room for improvement. Today's session promises to provide actionable strategies that can be implemented to achieve these enhancements. This webinar will last for approximately 45 minutes. After the presentation, we will allocate 15 minutes for Q&A. If you will have any questions for Dr. Chalaris, please send them to us and we will follow up with them after the presentation. Without further ado, please join me in welcoming Dr. Antonio Chalaris.
So thank you for the introduction. It's great to be here between friends in the EAStalk. So my background is in marine hatcheries and feed production, and I recently joined an agri-tech company called Devenish, and I thought that some of the members, the EAS members, might find interesting to see if there are any things that we can learn from agri-tech and we can apply directly into the aquafeed side of things. So at the beginning, I would like to give a very brief overview and basically compare the terrestrial farming and aquaculture in terms of history, and then move to the, if you like, the juicy bit of the presentation, the protein utilization and the moisture management tools that we have in our toolbox. And then at the end, we can have a discussion in the Q&A session. So let's take a step back in time. Animal husbandry has a long history. It starts when animals were first domesticated. We are talking about 13,000 BC onwards. By the time of early civilizations of the ancient Egypt, cattle, sheep, goats, and pigs were being raised on farms. But the important thing here is that domestication was not a single event. It was a process repeated at various periods in different places. And selective breeding, for example, for selective traits, was established as a scientific practice in the 18th century. And one of the most important breeding programs was with sheep in the UK. From the aquaculture side of things, another surprise, it did not really start from Greece. It started in China about 4000 BC. And the difference here is also that the first breeding program started in 1975 in salmon, and we only farm 1.5% of the known aquatic species. We farm about 500 species out of 30,000, when on the terrestrial farming, we have a much longer history focusing on a much narrower basket, if you like, of animals. So we're still on the very, very early steps of this process, and I believe we have to learn a lot from terrestrial farming, as there is no point basically to reinvent the wheel. But again, it's important to understand the terms. So when we mention agri-technology, agri-technology is basically the use of technology in agriculture, horticulture, and aquaculture with the aim of improving yield, efficiency, and profitability. And efficiency, productivity is not efficiency. Productivity is focusing on quantities of the products. We do more in a time frame and is assessed by how many items have been produced. Where efficiency, it's focusing on the quantities of the resources, the same amount of work in less time, and assess how well these resources have been used. So efficiency, productivity are completely different things. So do we need to be more efficient, or are we efficient enough as we stand in aquaculture, in aquafeeds? What we've seen is an intensification of aquaculture. So we add much more stress into the system. We see continuously rising health challenges. We see a lot of pressure to substitute marine ingredients. The cost of raw materials is not going to get any lower, that's for sure. And there is a huge pressure to reduce the environmental impact of the sector. So yes, indeed, there is a massive need to increase systems and feeds efficiency. A few words about Devenish. Devenish is a science-based agri-technology company. It's based in Belfast and it's developing sustainable animal nutrition solutions for approximately 70 years now. It's trading with over 50 countries. It's just, I couldn't really resist to share with you what a non-aqua performance house looks like. So I've got here the video at the bottom of your screen. You can see it's a very similar setup, replicated cages, feeding systems, and happy animals living the dream. It's very similar to aquaculture, but is using chicken instead of fish. So I thought you might find it interesting. But anyway, so we have a few of these performance houses scattered around the globe. We have 350 colleagues globally, and we are trading with over 50 countries. So the company has a very long history of innovation, starting from the 70s. Basically, we had the first piglet diet range launched, and then you will see in. Can you see my mouse? Don't know.
No.
No. Okay. Can imagine it then. So in 1998, we see. Come on, let me just try. Can you see it now?
Yes.
Yes.
Working.
Okay. So in 1998, basically, we had the first steps towards a non-debiotic growth promoters. And in 2004, we had the first discussions of omega-3 enriched chicken. In 2015, we have massive breakthroughs into the magnesium delivery systems. And the most recent one, in 2023, we have legal restrictions that come into place with zinc oxide. So Devenish is developing a product specifically focusing on the gut microbiome of pigs. So we go moving into the zinc-free era. But my personal favorite ones, too much technology for me now, Anna. Okay, boom. But my personal favorite ones is in 2001. We have here the launch of NatuPro. So we have with a ban on the use of mammalian protein in the EU and the implementation of restrictive use of fish meal in animal diets, coupled with some increased legislative pressures to reduce nitrogen output from animal production, there is an increased requirement for alternative protein sources. And that we see that in different species, not so much in fish back then in 2001. The pressure to reduce the fish meal use. And then the second one is moisture management, which I'm going to talk about it in a few minutes. Starting with protein utilization, we know that there is no mechanism for storing limiting amino acids the use of synthetic amino acids. It came into place a few years ago. So basically, to fill in the gap of substituting some raw materials. So we have here this graph. You can see the total availability of amino acids and the stomach and the gastrointestinal tract. You see with the pink line, this is how the dietary crude protein is being digested by the animal, nice and slowly. But the synthetic amino acids, when they came into the play, basically they came to fill in the gap of amino acid profile. But the problem that we had is that they were absorbed way too fast, they were released way too fast, and we had high wastage if they were not properly managed. And so the technology that's been developed, it's basically glycated amino acids, which are amino acids bound into sugars. So without the glycation, which is the covalent attachment of a sugar to a protein or a lipid, we're able to produce this yellow line here, which is basically the glycated amino acids. So the glycated amino acids, they fill in the gap between the synthetic and the dietary crude protein, the synthetic amino acid, the dietary crude protein. So we have a very nice and slow and controlled release of amino acids through the whole digestive process of the animal. So the first trials with this technology were in our friends, the pigs and the poultry, and we've seen encouraging results on increased protein accretion. The thing here is that protein is the most expensive component in aquafeed, so it was only natural to basically do trials, take the next step and do some trials and apply this technology as well in aquafeeds. So the inspiration behind this technology is the combination of these amino acids with the sugars. So Devamine technology is the technology that's been applied. It's an alternatively nutritional enhanced protein that allows a much more efficient absorption and utilization of amino acids, with the commercial name of NatuPro. It's been branded as NatuPro. The benefits that we've so the benefits that we've seen in aquafeed so far is the same control release of amino acids. We've seen better growth performance, and we have the ability to reduce protein, fish meal, and the use of synthetic amino acids without compromising the performance of the animal. And depending on the formulation, we see a formulation cost saving between 10 to 30 euros per ton. Another important aspect is we know that the oxygen demand to metabolize protein for energy use, it's higher compared to starch or fat. So by reducing the protein into a recipe, again, without compromising the animal performance, we have an opportunity to reduce stress during periods of high water temperature. Moving into the trials, so one of the trials that we did, it was with tilapia in the UK, in Pontus. So basically, we wanted to see if we can reduce the protein and the cost, obviously, of the formulator without, if not improving the performance of the animal. So it was very simple design. We had 4 different feeds in triplicate. So the first was a negative control where we just, actually, I'll just show you the whole recipes. It's much easier. So basically, the control back then, the cost of this recipe was about 426 euros, 5% fish meal and 33% protein. And we had the negative control, which we took down the fish meal from 5 to 2.5 and the protein from 33 to 31. And of course, the recipe cost went down by about 23 euros. And then we had the 2 different treatments by keeping the same specs as the negative control. So we have the same reduced level of fish meal, the same reduced level of protein, but we added 2 and 4% of the commercial product. Still, the recipe, it was a saving in the recipe despite the supplementation of the slow release amino acids. So what we've seen, it's basically as growth, a significant difference in both FCR 3.9%, and a decrease in the FCR in the animals. So basically, if you translate that into costs, we're talking of a saving of 16 euros per ton of feed. But if you associate the performance of the fish, we are talking at the final saving of 51 euros per ton of fish produced. And also, we have, if needed, another tool in our toolbox to tackle the low pollution and the high temperature and low oxygen condition. Another trial, again, based on the same technology and the slow-release amino acid technology, was this time conducted in Greece, in the Agricultural University of Athens, with sea bass. Again, the same aim, but with a species with different dietary requirements than tilapia, a bit more towards the omnivorous side of things. But we wanted to understand a bit more what's happening with the actual digestibility of the animal when using this technology. So it was juvenile European sea bass, again, 3 treatments in quadruplicates, which they were hand-fed 2 times a day. So look at that, I'm an expert in this now. So controlled diet, it was much higher protein than in tilapia. We had 46% and 15% fish meal. And then we had the negative control. We reduced the protein by 2%. And the fish meal went down to 13.5. And again, we kept the same specs for the slow release amino acid addition, 44% protein and 13.5% fish meal. You can see here description of the brief description of the recipe and also the cost that was reduced in both cases, of course. So we did not, in this case, we did not see significant differences in growth, performance, feed efficiency, or hepatosomatic index or carcass yield. But what we did see, it's basically increased digestibility in the lysine and methionine, which basically was not a surprise to us, as lysine and methionine are the key glycated amino acids in this technology. We're scratching our heads. We're trying to understand why we didn't see the differences in the growth performance as was expected. But the conclusion that we came is possibly because the fish, they were not challenged enough. We had a pretty bad winter that winter in Athens, and the temperatures were much lower to highlight any effects. However, we still saw the digestibility effects. And that's a study that was published last year in Rimini in the EAS conference. So, moisture management. In my opinion, probably the most valuable, one of the most valuable resources on Earth, water, is often underestimated and misused. Moisture, we know that is an important part of every single animal feed and aqua feed around the globe. When we have enough moisture, that will increase the physical feed quality, the meal structure, the starch gelatinization, the pellet durability, and ultimately is going to increase the feed intake and the digestion of the feed by the animal. So we know the literature shows that increased dietary moisture provides better absorption of nutrients by the fish and shrimp. There is no need to argue about it. However, we have some technical considerations, if you like. The feed companies have been controlling the maximum moisture content for a long time due to regulations that are often put in place to manage risk associated with high moisture content in feed. And these risks include feed spoilers due to microbial growth such as mold, yeast, and bacteria. So we would like to increase the moisture, but we can't really because of safety reasons. So mold growth can lead to mycotoxin formation. Therefore, controlling the maximum moisture level is important to ensure the feed quality. Apart from the maximum moisture levels, it's very important to consider the minimum moisture levels, which basically comes into controlling the quality and the quantity of the feed. overall, what we saw, it's basically moisture management. It's very important as has a huge impact on operations, environment, and the economic side of our business. So over here, we have the equilibrium moisture content, which is the EMC. It's basically the moisture content at which the material is neither gaining or losing moisture. So the EMC of a hygroscopic material surrounded at least partially by air is the moisture content at which the material is neither gaining nor losing moisture. The value basically depends on the material and the relative humidity and the temperature of the air at which is in contact. You see, the higher the temperature, the lower the humidity, the moisture decreases. The higher the humidity, the lower temperature, the moisture increases. And you see here, I've got a few examples of maize with wheat and soya. What we have here is raw material samples are taken as soon as the raw material arrives at the feed mill. So the matrix and the formulation is determined by these samples. The feed goes into storage, where the humidity and the temperature are as much as we can control. But assuming the temperature stays the same, ambient, the humidity will always change and will play a massive role into the final feed values. We have the example here again, that we keep the same level of the same temperature across the board, 21 degrees, but just by different humidity levels. You can take the extreme example of soya. At 70% humidity in the environment, we have 11.9% moisture into the soya. When the humidity drops to 30%, the 11.9 has dropped to 5.5%. So what does really matter to us is when we formulate, we have a maximum safety level, let's say 12% in aqua feeds, that we must not go above that, mainly for safety reasons, quality. And then when we get our samples, when the raw materials arrives, we have what we call the formulated moisture. We formulate based on that moisture. But what is actually happening, because the humidity is changing when we store the raw materials, is quite a lot of the times something completely different. So it's a huge gap between the actual moisture that's happening into the feeds and the formulated moisture. So water activity. So water activity is basically the ratio between the vapor pressure in a food to the vapor pressure of pure water. In other words, it predicts whether water is likely to move from the food product into the cells of microorganisms that might be present. Dry raw materials don't just simply absorb water, they become hydrophobic due to a tightening of cell walls as internal moisture is depleted. An imbalance of water either side of the cell walls hinders osmosis. So surface tension issues arise and water cannot initially penetrate the cell wall. What we have seen is that water activity level that limits the growth of the vast majority of pathogenic bacteria is at 0.9. A water activity of 0.7 is the lower limit for spoilage mold, and the limit for all microorganisms is 0.6. So drying aqua feed below a critical water activity level will control mold and microbial growth. In most cases, in most factories, 0.65 is the threshold for water activity. If we have anything higher than that, we have to change something into our system. It's too risky for the feed quality. So historically, what's been happening when we want to manage moisture into feeds, it's basically a blend of organic acids and surfactants. We're focusing either on mold inhibition, microbial inhibition, and with another product called E484, basically we want to break down the surface tension of the water to allow these particles to spread through the ton of feed. But what we see as the latest innovation, which basically is a patented process from Devenish, it's a unique blend of glycerol esters of propionic acids and surfactants. So smart moisture is a technology that is much more concentrated than all the other solutions that are out there, simply because of the stability of glycerol esters. So the propionic acid esterified to glycerol is the patented process used to buffer and stabilize propionic acid. The way that this technology works is we have the surfactants, which basically reduce the water tension, allow the water to spread homogeneously through the mix. It creates a larger surface area of contact between the water and the mass and allows a much better water absorption. As the water gets absorbed into the mass, the free water is turned into bound water. Thereby, we reduce the water activity. The lower the water activity, it results in reduced water availability for microbial growth, molds, yeast, and bacteria, as we saw before. So when we reduce the water tension for surfactants, basically they open the door for organic acids and glycerol to penetrate into the feed particle. The organic acids have a preservative effect, slowing down microbial growth. And glycerol retains moisture in feed. Glycerol can hold up to 1,000 times its own weight. It's been heavily used in the pharmaceutical industry. So the role of surfactants, basically, so the surface tension in this chart is measured by dynes per centimeter. Distilled water at a temperature of 25 degrees Celsius has a surface tension of 72 dynes per centimeter. The lower the number, the easier for the moisture to penetrate the materials. So it is widely understood that surfactants can further reduce the surface tension of water, increasing surface area. In Europe, in animal feed industry in Europe, there is only one surfactant registered, which is the E484, as we've said. This is the efficacy of this surfactant is illustrated here on this line, which takes it down to 56 dynes per centimeter before it reaches the saturation point. This glycerol ester technology that I'm referring to through smart moisture basically improves further the surface tension reduction, as we can see here with a blue line, and we take it down to about 40 dynes per centimeters. But actually, the best way to show the efficacy of surfactants is just by showing you this video of a quick little test, where we can see by reducing the surface tension, we can have a much greater penetration of moisture into the feed. So this little video is showing the penetration of water into a few different sheets of paper, but it's exactly the same principle in feed. So we have 2 drops of water. The one on the right is just water, and again the same with smart moisture. But on the left side, we will add just 1 drop of this technology, and let's see what's going to happen. So you see it's an instant reduction of the surface tension and allows a much better penetration into the pieces of paper. And actually in this trial, we had up to 7-8 pieces of sheet that became wet. So that's exactly what we want to achieve in the feed, a much better penetration of moisture into the feed ingredients. So this technology is being applied since January 2020. We've run over 65 commercial trials in extruded and pelleted feeds across all the different species that we are dealing with. What we've seen is important energy savings, increase in throughput, great moisture retention, great starch gelatinization, and specifically about starch gelatinization, it immediately just click in our heads that if we manage to reduce starch gelatinization by 1% in species such as Salmon, for example, they have very expensive formulation, very nutrient dense. That will mean a saving of about 7 to 10 euros per ton. But starch gelatinization also plays a very important role into the quality of the feed, simply because it improves the durability. We have less dust, less chips. It's a much more durable pellet. In cases also that the feed is being fed through the pipes, so we have a much stronger pellet. And also water activity, as we mentioned before, the target is to be below 0.65 in extruded feeds and 0.70 in pelleted. But to me, the most important aspect here is the average energy saving across all trials. We see here the energy consumption based. So energy consumption baseline is you see on the 0, it's either negative or positive control. So the solid bars that we see here are basically the smart moisture trial against the negative control, no moisture addition. And the hashed bars here are the smart moisture trial against the positive control. We only add extra water. We have quite big variation between all the different trials that we did, but this is down to that technology has been tested in different production systems and different operations. We see variation from 0 to 23%. Every system is different extrusion, different application method. So it's kind of expected. But overall, what we saw, an average saving in energy of 5.9%. So one trial that we did, every customer that we see has different requirements. So one of the trials that we did, the requirement here from the market was basically to reduce the feed moisture below. It was basically to reduce the risk of microbial growth. That customer was exporting feeds to warm countries, so microbial growth was the #1 priority for them. So the way they were tackling it, they were keeping the feed moisture below 6%. So we wanted to see if we can change that by having a controlled diet, exactly the same practice as they were doing, 5.7% moisture, and 2 different treatments, the same level of this technology, but with increased level of moisture to 8.5 from 5.7 and 9.7%. For this application, we applied this technology into the mixer with all the liquid additions. So we made a blend with the liquid stuff that we were putting into the mixer, and we put as well the smart moisture, and it was sprayed with nozzles into the dry mixer. And what we saw is that the water activity was stabilized across the board below the 0.55, which are more than safe in terms of risk in all the different moisture levels. The second trial, the priority here was basically to see the energy usage and the throughput improvement of this product. So the design was a bit different. We had a standard control diet, which we were using a standard mold inhibitor, and then we increased the moisture by 1%, and then we increased the moisture into the mixer by 2%. So what we saw here is improvements into the load reduction. We saw a 10.1% load reduction and 11.4% change into the specific mechanical energy that was needed with these treatments. And in terms of throughput, you see here the actual numbers and 2 different treatments. Actually, I would like to apologize, is 0.1% and 0.2%. It's not 2%, it's 0.2% and 0.1%. But the throughput improvement that we saw, it was 10.2 and 18.3% compared to the control. So we've learned a lot so far, but there's even more out there which we can explore from the agri side of things. And hopefully I am on time. Anna, I don't want to upset you too much. So thank you very much for your time. And please let me know if you got any questions. Thank you.
Thank you very much. Anthony, feel free to leave the presentation. So leave the slide here. It was amazing presentation and you explained really, really well everything. So I'm opening now the Q&A. We received something from Andre Dumas, very interesting. Can you share the essential amino acid composition of NATO Pro? Thanks.
Well, I can't say the exact breakdown. We can see some values. Yes, definitely. We have a matrix that you can take into consideration in your matrix, and you can see. Yes, we can to a certain extent. That's the answer.
Okay.
It's methionine and lysine, the main things, the main components.
Mm-hmm. Thank you. The next one is smart moisture dose is 0.5 gram per kilogram. My question is, how can you ensure the distribution of the smart moisture is even in the mix?
That's actually, yeah, that's a very good question. So, so we can recover the propionic acid. So if we have any questions about the efficacy of the application, we can take samples at the end of the final product and analyze it. So, but to safeguard that we have an even distribution, there are protocols in place about the actual application of the product. It can either be directly into the mixer with different liquids, or it can be mixed with water and be applied in the preconditioner. So we have specific number of nozzles. The higher the better, but 4 to 6 normally works with some specific specs that they spray that solution into the mix. And we've seen that for about 3 minutes, if I'm not mistaken, normally in the mixer, that should have a very homogeneous mix. But again, it depends on the size of your mixer and the formulation that you have. But yes, there are tools that you can actually assess it and see if you got a homogeneous blend.
Thank you, Antonis. The next question I have for you is, what have been the biggest challenges that you like to transfer this technology to aquaculture?
So the biggest challenge is that the bigger the companies they become, unfortunately, we see everybody goes into silos, into different silos. So if you got something that has to bring together more than one silo, such as like a moisture management solution, which you need to bring formulators, engineers, and the finance people together, the biggest challenge is to go to the right gatekeeper, is go to the right people and bring them together at the same time. So you can have a conversation and you can have and design a proper trial. So going to the right people and bring the right people together is by far the biggest challenge I've seen. Everything else we can work around it, but sometimes working with people can be challenging.
But it's important that you found the best people in this.
So far, I can't complain. Suppliers, colleagues, customers have been extremely lucky and privileged.
That's great. That's great to hear. The next question I have for you is, do you have any plans to run more experiments in the lab and in the field with the different species and the Naturo Pro?
Yes. I mean, at the moment, the focus is on this glycerol esters technology, on the moisture management. So we do a lot of trials with customers and with third parties to further develop our understanding on how it works in extrusion primarily, and then a bit more with the pellet. But the main focus is extrusion. And on the second stage, we're going to continue the biological trials with NatuPro and emulsifiers and some other products that we have in the pipeline, focusing more on the health side of things. It is in the pipeline, but it's coming up within the next few months.
Mm-hmm. Thank you, Antonis. Can you tell me how has aquaculture industry responded to this technology so far?
really positively, but
Mhm.
again, personally, I'm a bit disappointed by the actual bureaucracy slowing down things.
Mhm.
So it's going very fast. We have some very loyal customers. We have some very, very good collaborations already in place that very open, that basically we are partners, we work together. They're very open on the feedback, positive, negative. It's been working really, really well. So the aqua industry has responded really well. And we have a lot of projects in the pipeline together. So it's really, really positive, really positive.
Perfect. I want to say to everyone that this is the final reminder for you to send any questions that you have for Dr. Chalaris. So feel free to send them to the chat. My next question for you, Antonis, will be, what are the next steps in terms of innovation on the aqua side of Devenish?
So in terms of innovation, Devenish has a lot of experience in gut health, in piglets. Especially, we learn a lot on the zinc-free era. We have a huge basket of raw materials that we've done extensive research. And the next stage is basically learn from this experience and see how we can implement all these tools that we have on the gut health and the water quality side of things. We've seen that the water quality in the recirculation systems, in ponds, even flow through, there's huge space for improvement in terms of the microbial profile and how that affects the gut health of the animal and the performance of it. So water quality and gut health, I would say, are the next steps for us.
Perfect. And the next question that you received from the audience is, have you used Natura Pro in carnivorous fishes to reduce or replace fish meal and oil?
In fully carnivorous species?
Yes.
I would imagine probably like salmonids and stuff like that. We haven't, no. We haven't. No. I mean, the industry has already done huge steps in salmonids to reduce fish meal to very, very low levels. So I'm not sure that there's any space to take it any lower than that, to be honest.
Good. We still didn't receive anything else from the audience. So do you want to say the last comment? Or
it seems that we cover everything then.
Yes, I mean, I told you, like, you explained really, really well everything. So I guess most of the things are quite clear to the people in the background.
Glad to hear that. Well, it's a whole new world out there. We just need to explore it and learn from each other. That's all I can say.
We didn't receive anything from them. So in case you would have any questions for Antonius, you have his email address here, and feel free to send him an email with any questions you have. I will wrap up our EAStalk webinar for today. And I would like to thank you, Dr. Chalaris, for enlightening presentation on improving aquafeed. We really enjoyed your presentation, and as you could see that we did not receive that many questions, so it means that everything was well explained at the end. And we have learned a lot from you today. I wish you all the best with development of Devenish and with every next step that you do in aquaculture sector. And thank you very much all for attending and participating in today's session. I will send you an email, follow-up email with the link of this webinar. Thank you very much. And before we close, Antonis, we just received a comment from Elena Mente. She said, congratulations. And I agree with her on this.
Thank you. Thank you all.
Thank you.